All right, guys, this is Coach Lambert. We're going to go over the second half of 9.4 today. This will be about a 10-minute lesson going over rationalizing the denominator. And guys, rationalizing the denominator means we have to get rid of the radical that's in the denominator. We can't have that. It's much easier to deal with fractions with radicals if there's no radical in the denominator. So we need to get rid of the radical that's in the denominator. And remember, if we multiply the numerator and denominator by the same thing, it really doesn't change the value. So that's actually what we're going to do. We're going to get rid of this radical by multiplying the entire fraction by 1. So because this denominator is the square root of 2, I'm going to multiply both the top and the bottom by the square root of 2. And if I do that, the square root of 2 divided by the square root of 2 is just 1. So I'm really just multiplying the fraction by 1, which doesn't change the value. So we're not changing the value. We're only getting rid of the radical, the square root in the denominator. Watch what happens. I multiply square root of 2 times the square root of 2, which we know is the square root of 4, which is actually 2. The square root of 5 times the square root of 2 is the square root of 10. And now since the 10 is not a radicand that has a perfect square that goes into it, and since there's no radical in the denominator, I'm done. That's fully simplified. I just rationalized the denominator by getting rid of the radical that's in the denominator. Okay? Let's go ahead and try a few more examples. Let's do another easy one. 2 over the square root of 7. I got to get rid of this radical in the denominator, so I'm going to go ahead and multiply it by the denominator. Square root of 7 by the top, square root of 7 by the bottom. The square root of 7 times the square root of 7 is just 7. 2 times the square root of 7 is 2 square root of 7. I just rationalize the denominator by getting rid of the radical in the denominator, by multiplying it by itself. Let's try another one. Square root of 5 over the square root of 12. Okay, I can't have the radical in the denominator, but this denominator is not fully simplified. I know there's a perfect square that goes into it. I can break the square root of 12 down into the square root of 4 times 3. And the square root of 4 is 2. So it's 2 square root of 3 over the square root of 5. So I'm just going to bring that over here. But I can't stop there because I still have this radical in the denominator. So what we want to do now is we want to multiply by the exact same radical, okay? I'm not worried about the whole number in front, but I'm worried about the square root of 3. So I'm going to multiply both the bottom and the top by the square root of 3. So watch this. The square root of 3 times the square root of 3 is 3. 3 times 2 is 6. The square root of 5 times the square root of 3 is the square root of 15. I just rationalized the denominator. So the very first thing, I hope you learned from it. The very first thing, this was our original question. You have to see if you can simplify the denominator first, before. Some people want to just multiply by the square root of 12 to both. Do not do that. Simplify the denominator first if you can. So if you know there's a perfect square that goes into it, make sure you simplify that first. Okay? All right, a couple more, guys. Let's do square root of 1 over 18x. Keep in mind what our quotient rule said, guys. Our quotient rule said that we can split this up into the square root of 1 over the square root of 18x. Okay? Oh, I know a perfect square that goes into 18, so I can simplify that. So square root of 1 over the square root of 9 times 2 times x. The square root of 9 is 3, so bring it out front. So I get the square root of 1 over 3 times the square root of 2x. Oh, I can't leave this as my final answer because I still have a radical in the denominator. So I have to multiply both the bottom and the top by the square root of 2x. The square root of 2x times the square root of 2x is 2x. 2x times 3 is 6x. The square root of 1 times the square root of 2x is the square root of 2x. We have rationalized the denominator. Hold on one sec. That's it. All right. Now, what happens when we have more than one term in the denominator? This will be the last thing we do. I want you guys to remember what the word conjugate meant. That was when we were multiplying binomials, and the O and the I in FOIL cancel. So we only get two terms. We're going to have to remember what conjugates means in order to simplify this. So check this out. Two over 4 plus the square root of 3. I have two terms in the denominator, and one of them is a radical. I got to get rid of it. Anytime you have two terms in the denominator, and one of them is a radical, you must multiply both the top and bottom by the conjugate of the denominator. Remember, 4 plus the square root of 3, its conjugate would be 4 minus the square root of 3. And guys, I got to multiply that by the top and the bottom. Okay? So watch what happens on the bottom. 4 times 4 is 16. The square root of 3 times negative square root of 3 is negative 3. On the top, 2 times 4 is 8. 2 times negative square root of 3 is negative 2 square root of 3. I can go ahead and reduce the denominator here. 16 minus 3 is 13. 8 minus 2 square roots of 3 over 13. All right. Now, sometimes in your answer, you get like this the way you can simplify it a little bit further, okay? So I want to do one example like that, and then we'll call it quits, okay? So anytime you have two terms in the denominator, to rationalize the denominator, you have to multiply by the conjugate. And you multiply by the conjugate to both. And remember, when you multiply conjugates, you do the first term in the first term, the last term in the last term. The O and the I cancel. So when I have two terms in the denominator, multiply by the conjugate to rationalize it. And the last thing we'll do, let's say they have a question like this where they wanted you to simplify this. (12 minus the square root of 18 over 9). Well, hopefully you're asking yourself, well, Coach, there's not a radical in the denominator. That is fully simplified. I don't have to do anything else. And you would be partly right, okay? It's not fully simplified, but I don't have to rationalize the denominator. I don't have a radical in the denominator. But what I do have to do is I have to simplify the square root of 18. So 12 minus, break down the square root of 18 into 9 times 2. Now I can actually take the square root of 9, which is 3. I bring it out front. So I get 12 minus 3 square root of 2 over 9. And guys, 12 minus 3 times the square root of 2, it's two terms. Guys, I have a common factor. 3 can go into both of these. So I have to factor out a 3, which leaves me with 4 minus the square root of 2 over 9. So notice I had two terms up top. I recognize that 3 could go into both of them. I could take a 3 out. So I factored a 3 out, which left me with this. Now I can reduce 1 and 3. So my final answer is 4 minus the square root of 2 over 3. Okay? So it's very important on the last step, don't box this answer if there's a common factor we can take out and reduce. Okay? So I hope this helped going over these examples of rationalizing the denominator. Homework tonight is My Math Lab homework number 10. It's due at 8 a.m. tomorrow morning. And all it's asking you to do, guys, is to go through these examples like we did. Rationalize the denominator and make sure you can simplify and it's in simplest form. Thanks, guys.